let's take a peek at our learning targets and our success criteria. So, my learning target for this particular video was to state the significance of a chemical formula. That's my learning target. Now, what kind of success criteria do I need to get that learning target? Well, ladies and gentlemen, I can, and we hit 2 of these, I can name monoatomic ions. I can identify multivalent ions. Now, that's the one that we didn't hit. All right, I'm going to show you today in our review notes how to identify multivalent ions. The final success criteria that I have, I can write the formula for binary ionic compounds. And remember how we just stated that in order to do so, I'm going to need least common multiples. I'm going to need crisscross method. Now, what does this chemical formula tell you? Can anybody answer that question? Tell me something that this chemical formula tells you. Gage, what do you think? All right, it tells me how many atoms of each particular element that I have. Excellent. This, by the way, is glucose. Okay, so this is glucose right here. So 6 carbons, 12 hydrogens, 6 oxygens. Anything else that thing tells you? Let me ask you this. Does that tell me what kind of bonding I have going on? What do you think? Bryson, what do you think? Does that tell me the bonding I have going on? No? Okay. What do we know about bonding? Types of bonding do we have? And that was a type of what type of bond? Covalent bonding is one type of bonding. What's the other type? Ionic bonding. So can I tell whether this is ionic or covalent by looking at that formula? What's an ionic bond consist of? This is last unit. Okay. What's an ionic bond consist of? Metal and a nonmetal. Do I have a metal and a nonmetal here? No. So what type of bonding is this? Covalent bonding. So does it tell me? Absolutely. Absolutely, it tells me what type of bonding I have. So this is a covalent bond because I have nonmetals bonding together. You're going to learn later on that it's going to tell us some other things. Moles, okay? In this case, molecules. We're going to get some masses. So there's all kinds of different things the chemical formula will tell us. Now, right here, this chemical formula. What type of bonding do I have here? What type of bonding do I have here? What do you think, Eric? What type of bonding? You got a 1 and 2 shot. Let me give you a hint here. Is this a metal or a nonmetal? Yep, calcium is a metal. So what type of bonding do I have here? Metal bonding? I only have 2 types of bonding. Okay, what are the 2 types of bonding we just said? Huh? Okay. Well, if you would listen, because, Bryson, can you tell them again the 2 types of bonding? Okay, this is ionic bonding. All right. Now, when I have ionic bonding here, and this one right here, actually, This is a good one here because this is a polyatomic ion. We're going to learn about polyatomic ions tonight. But if he would have said anything other than I don't know, he would have been right. Because this right here is covalently bonded. So in this particular one, I have ionic and covalent bonding. So the only way you could miss this is by saying, I don't know. Now look at this right here. What does this tell me? What does this tell me? How many oxygens do I have here? So as I look at this, how many oxygens do I have? Well, these parentheses we treat almost like we do in math, okay? Almost like we do in math. So I distribute this 2 to the 4 here, oxygens, and to the 1 right here. If I don't have a number, like I don't have right here with the phosphorus, it's 1.
Chelsea Davis, if you're in the building, would you please come to the office, please? Chelsea Davis, come to the office, please.
So if I look at this, what is 4 times 2? 8. So I have 8 oxygens, and I have 2 phosphorus, 3 calcium. So that's telling me the amount of atoms that I have of each element. Now, my next one is CaSO4. Now, notice I don't have any parentheses around this SO4. Okay? If I only have one of the polyatomic, and you'll learn this tomorrow, if I only have one of the polyatomics, I do not need parentheses. So this tells me that I have 1 calcium, I have 1 sulfur, and I have 4 oxygens. One of the success criteria was monoatomic ions. So go ahead and take out your ion sheet, take out your periodic table. Ion sheet, periodic table. Grab Phillips too. Now, as we're looking at this, sodium. When I'm dealing with sodium, here is my electron dot notation for sodium. So as I look at sodium, and I know where sodium is on the periodic table, right? It's a group 1 alkali metal. So I look at the sodium, and I know that it has 1 valence electron, correct? Now, metals want to get rid of electrons, right? So this sodium is going to get rid of that electron to give it a +1 charge. So sodium is a cation. So the sodium ion is +1, a cation. Here is chlorine. Here is the electron dot notation for chlorine. We know that chlorine is 1 electron away from filling its outermost energy level, correct? So what nonmetals tend to do is they're going to want to gain an electron. So if chlorine gains an electron, it now has 17 protons, it has 18 electrons. So the net charge, 17 pluses, 18 minuses, the net charge is going to be a 1 minus. So the chlorine ion, all right, and here's where it's a little bit different. When we're dealing with monoatomic anions, meaning that they are negative, we take this INE and we replace it with IDE. So this is the chloride ion. So when we're talking about chloride, you know that you're dealing with the element chlorine. Now, does it make sense that this sodium wants to dump a single electron? It wants to get rid of an electron. This chlorine wants to gain an electron. Does it make sense that the sodium gives its electron to the chlorine, and now we have a bond due to the positive and negative charges? Absolutely. That's ionic bonding that we just talked about. Okay? That's ionic bonding that we just talked about last unit. Now, let's look at calcium here. Calcium has 2 valence electrons. So calcium wants to get rid of 2 electrons. Well, here's chlorine. Chlorine will take 1 of them. However, I need to have 2 chlorines because calcium has 2 electrons. So when I do so, that electron's going to go there. That electron's going to go there. So now I have a 2+ charge. I have 2 -1 charges. But what is my net charge? What's the net charge between this whole thing here? 0. So I have to have a net charge of 0. So in order to have the bonding between calcium and chlorine, I need 2 of the chlorine atoms, and I only need 1 calcium atom. Now, let's start relating these into writing the particular compounds. Now, find aluminum on your periodic table. Okay, find aluminum on your periodic table. What does aluminum want to do charge-wise? What's it want to do charge-wise? Zoe, what do you think? It wants to lose 3 electrons. So what are you anticipating its charge being? +3. Find aluminum now on your little charge ion sheet here. Okay, I like this ion sheet because it matches and shows you the periodic table, right? So find aluminum there. Is aluminum a +3? Absolutely. So I've got this aluminum here. 3+. Now, what about oxygen? Cooper, what can you tell me about oxygen? Oxygen wants to gain 2 electrons. So what do you anticipate oxygen's charge being? 2-. I wrote with the green pen and it's in red. All right, so I've got 2+, or excuse me, I've got 3+, I've got 2-. Okay? Now, we can do this a couple of different ways. All right? We could do the crisscross method. If I do the crisscross method, then I'm going to cross this 3 down to the oxygen and this 2 over to the aluminum. So I'm going to get Al2O3. Now, the trouble with the crisscross method is it's not always correct. There are times, and I'll show you one here later on, there's times when I use the crisscross method that it's wrong. So, what I like to do is I like to use the least common multiple. So I come back to my original starting, and I have Al 3+, and I have O 2-. What is my least common multiple of 3 and 2? 6, right? So what I need to do is I need to get both of these to 6. Well, there's 6. There's 6. So in order to do this, I can see that I need 2 aluminums, and I need 3 oxygens. Al2O3. Now, what are some problems that I typically see? Ladies and gentlemen, when we have subscripts, they are telling us the number of the particular atom. Now, one thing I see wrong that people do is they do this. They have Al and they put a 2O3. They put them up there, kind of like superscripts. When I look at that, those are where charges go. Superscripts are where charges go. Subscripts. Subscripts are the number of atoms. So make sure that you don't do that. Here is barium bromide. Carter, what are your thoughts on barium? Carter's saying that barium's going to be 2+. I'm going to agree with you. How did you get that? He's looking on his periodic table. He knows that barium is an
Interruption, but if I can have the following students for a moment.
Carter knows that barium is an alkaline earth metal in group 2. Group 2 has 2 valence electrons that it would like to get rid of. That's why it's a 2+. What can you tell me? Philip, what do you think about bromide? First of all, bromide is telling you you're dealing with what element? Bromine. What do you think about bromine, Philip? Bromine is going to want to be a 1- because it's a halogen. It wants to gain 1 electron. So, if I look on my ion sheet, does Ba 2+ match up? Yes. Does Br 1- match up? Yes. Okay. So, when I write my compound, okay, what's my least common multiple of this particular one? Harley? 2. All right, so I've already got Ba there, so I'm going to need 2 of the Br. So when I write out my formula, BaBr2 as my subscript. Are we okay with that? We okay thus far? I got thumbs up. Let me see. All right. Now, this is bringing something new to the table. All right? Because I have this right here. IV. What is that IV right there? Anybody know? What are those called? Roman numerals. I remember back when I was a kid, Mom and Dad had a clock. Didn't have any numbers on it. Had all Roman numerals on it. So that's how I learned my Roman numerals, at least up to 12, by the clock. But this is a Roman numeral. And IV is the Roman numeral for 4. Now, look at lead on your periodic table. Find lead on the periodic table and point to it. Now, above the symbol for lead, there are 2 little black numbers. What are they? Grace, what are they? +2 and +4. Now, what are those numbers? Okay? What are those numbers? Look at the key. What is it? The oxidation states. And lead has 2 oxidation states. Now, when we talk about cations, positive ions, they are sometimes what we call multivalent. Okay? Multivalent means that it could take two different charges or more. Okay? Many charges. So if you look at an element that is, like I said, we're dealing with cations, so it's going to be a metal. If you look at a metal, and that metal has more than one oxidation state, it is multivalent. If it is multivalent, we need to have this Roman numeral right here in order to tell us which one. Okay? Look at zinc. Point to zinc. Is zinc multivalent? It is not. So zinc only takes a charge of +2. Look at iron. Find iron. Point to iron. Is iron multivalent? Audrey, what do you think? Is iron multivalent? Does it have more than one black number above it? Huh? Yeah, it does. So is it multivalent? Yes. Do I need Roman numerals? Yes. Hunter? Remember I said we're dealing with cations. Okay. We're dealing with cations. We'll get to anions later. Okay? We're only dealing about cations now with the oxidation states. Look at chromium. What do you think about chromium, Josh? Is chromium multivalent? Yes, it is. What charges can chromium take? +2, +3, +6, right? Chromium is multivalent. Look at his next door neighbor there, manganese. Manganese, +2, +3, +4, +6, +7. Is manganese multivalent? Definitely. Definitely. Okay? So do you think you can tell whether something's multivalent or not? All you have to do is look at those oxidation numbers. Now let's look back here. Lead 4. This Roman numeral is actually telling me that I am dealing with lead Pb, which is 4+. What do you know about oxygen? Jackson, what do you know about oxygen? What are you thinking? It's going to be an ionic bond. What charge is oxygen? What I'm getting at, what charge do you think oxygen is going to be? -2. So right here, ladies and gentlemen, right here was the instant that I told you that if you crisscross this, because you're going to crisscross a 4 over here, you're going to crisscross a 2 here, you're going to get P, you're going to get PB2O4. Now, ladies and gentlemen, this is an instance where the crisscross does not work. Crisscross does not work. Now let's go back here. Let's go back here to what we just had. What is my least common multiple here? 4, right? So I'm going to need 2 of those to get to 4, right? So my correct formula is PbO2. So can you see how doing it that way and doing it the crisscross way, how the crisscross gave me a bad answer? All right? Crisscross is not always correct. Iron 2 sulfide. Roman numeral 2. Those aren't II, those are Roman numeral 2. So find iron. What charge can iron take? What charge can iron take, Hunter? A 2 plus or a 3 plus. Sometimes I've even said, and it's not on there, I've even seen iron take a 6 plus. We're actually going to do a lab later on this week in which we are going to identify whether we have iron 2 or iron 3. Okay, so we will do that in the lab later on. But this Roman numeral is telling me that I am dealing with iron 2. So I have Fe 2 plus. Gauge sulfur. What kind of charge is that going to give me? Sulfur is going to be a -2. So, what's my least common multiple? 2, right? Is my net charge already 0? Yes. So, if I'm writing the formula, it's FeS. So FeS is the formula for iron 2 sulfide. Now, what I want you to do, this is the last of our examples. What I want you to do is I want you to work this one on your own. Okay? Work this one on your own in your notes. Anybody want to come up to the board and write the answer? Go ahead. What do you think? Give them a thumbs up or you give them a thumbs down? Now, this was the point, folks, and I had a little conversation over here, and the question was, how do I know which oxidation state to use with phosphorus? Now, remember, we're talking about, right now, ionic bonding, correct? What does phosphorus want to do? It wants to gain 3 electrons, right? We won't deal with all those different oxidation states with phosphorus until we talk about covalent bonding, okay? We talk about naming molecular compounds. We're only worried about naming ionic compounds now, and if you're dealing with phosphorus, it's going to gain 3 electrons. Look at chlorine. How many oxidation states does chlorine have? A bunch, right? +1, +3, +5, +7, -1. See all those? But as an ion, what's chlorine going to do? It's going to gain 1 electron. So as an ion, what charge will chlorine be? -1, the chloride ion. Okay?